In the infinite void of space, a lone spacecraft, humanity's farthest traveler, has just shattered everything we thought we knew. For 45 years, Voyager 1 has journeyed through the cosmos, a silent sentinel carrying the hopes of a young species. It was launched in 1977, a time when disco ruled the airwaves and computers were the size of rooms. Built to last a decade, maybe less, it defied every expectation, soaring past Jupiter, past Saturn, and into the uncharted abyss of interstellar space. But after decades of groundbreaking discoveries, something unthinkable happened. Voyager 1 went silent. The most distant human-made object in history, over 15 billion miles from Earth, stopped sending coherent signals. For months, it drifted alone, its transmissions reduced to gibberish, a faint whisper lost in the cosmic static. Scientists feared the end had come, that the mission that redefined our place in the universe was over. Until now. Suddenly, impossibly, the signal returned, clear, precise, and carrying data that has left the scientific community reeling. A Nobel Prize-winning physicist has issued a stark warning. This isn't just a discovery. It's a revelation that could rewrite the laws of reality itself. What has Voyager 1 found at the edge of the cosmos? Why are experts whispering that this could be the key to unlocking the greatest mystery of all time? Stay with us, because this isn't just a space mission. This could be humanity's first glimpse into the unknown. The story of Voyager 1 is one of audacity and cosmic luck. Launched in 1977, it was part of a mission to explore the outer planets, a bold leap into the unknown. But what made this journey possible wasn't just engineering genius. It was a rare alignment of the planets, a celestial event that happens once every 176 years. Jupiter, Saturn, Uranus, and Neptune lined up like stepping stones, allowing Voyager to slingshot from one to another, using their gravity to propel itself faster and farther than any spacecraft before. They called it the Grand Tour, a once-in-a-lifetime chance to glimpse worlds humanity had only dreamed of. Voyager 1 delivered. It sent back images of Jupiter's swirling storms, Saturn's majestic rings, and the pale blue dot of Earth from a distance so vast it humbled us all. Then, its primary mission complete, it was flung outward, beyond the planets, into the vast emptiness of interstellar space. No one expected it to survive this long. Powered by a plutonium battery, slowly fading, with less computing power than a modern smartphone, Voyager 1 has endured cosmic radiation, micrometeoroids, and the relentless cold of deep space. Yet it kept going, sending back faint signals across billions of miles, a testament to human ingenuity and the unyielding drive to explore. But in 2024, something changed. Voyager 1's transmissions, already weak from its immense distance, became incoherent. The data was corrupted, a jumble of ones and zeros that made no sense. For months, engineers worked tirelessly, sending commands across the void, hoping to coax the aging spacecraft back to life. Each signal took 22 hours to reach Voyager, and another 22 hours for a response to return, if it returned at all. The silence was agonizing. This wasn't just a machine failing, it was the loss of humanity's farthest eye, our only window into a realm no one had ever seen. Then, in a moment that felt like a miracle, the signal cleared. Voyager 1 was back online, its data readable again. But what it sent wasn't routine. It wasn't expected. It was impossible. The data revealed something extraordinary. Voyager 1 was detecting phenomena that defy every model of interstellar space. Scientists expected the region beyond the heliopause, the boundary where the sun's influence ends and the interstellar medium begins, to be relatively calm, a vast emptiness dotted with sparse particles and weak magnetic fields. But Voyager's instruments told a different story. There were intense plasma fluctuations, chaotic shifts in magnetic fields, and a surge in charged particles that seemed to come from nowhere. One researcher described it as a cosmic storm with no source. The readings didn't match any known stellar phenomenon. Pulsars, supernovae, even distant galaxies. None could explain the turbulence Voyager was encountering. Stranger still, the spacecraft's trajectory was off. It was drifting slightly, as if nudged by an unseen force. Not a star, not a planet, not even a black hole. Something else was at play, something that shouldn't exist. The most shocking discovery came from the cosmic rays Voyager was detecting. These high-energy particles, usually scattered randomly across space, were aligned in a way that made no sense. Their paths were bending, twisting, as if guided by a structure invisible to our instruments. Magnetic field lines, which should have been uniform in interstellar space, were spiraling into patterns that suggested a hidden framework. One scientist, staring at the data, whispered, "It's like Voyager is flying through a cosmic web, something holding the universe together." But what could create such a structure? The answer, according to a Nobel laureate, might lie beyond the boundaries of our understanding. In a rare public statement, this physicist warned that Voyager's data points to a domain where our laws of physics may not apply. The implications are staggering. Could Voyager 1 have crossed into a new kind of space, a transitional zone where reality itself shifts? Is it brushing up against the edge of another dimension, a multiverse, or something even stranger? Among the flood of data, one signal stood out, a rhythmic pulse, faint but unmistakable, embedded in the noise. At first, engineers thought it was interference, a glitch in Voyager's aging systems. But the pulse was consistent, repeating at precise intervals, unlike any natural phenomenon in the cosmos. It wasn't a pulsar's steady beat, nor a quasar's erratic flare. It was structured, almost deliberate. Then came the chilling realization. The pulse seemed to respond. When Voyager sent its regular data bursts back to Earth, the pulse's intensity spiked slightly, as if something out there was listening, reacting, maybe even replying. The idea was dismissed as fanciful. After all, Voyager's instruments are decades old, prone to errors. But the pattern held. Visualizations of the data revealed something even more unsettling. The magnetic field variations, when plotted over time, formed a shape, a spiral, symmetrical and repeating, like a blueprint etched into the fabric of space. It wasn't random. It wasn't noise. It looked like a design. Theories began to swirl, each more audacious than the last. Some suggested Voyager had encountered a gravitational lattice, a network of forces woven into the universe itself, invisible until now. Others proposed it could be the signature of an artificial structure, something built by an intelligence far beyond our own. The idea sounds like science fiction, but the data is real. Voyager 1, a relic of the 1970s, is detecting patterns that no supercomputer on Earth can fully explain. Even more bizarre, the spacecraft's internal systems are behaving erratically in ways that defy logic. Its orientation sensors, designed to track its position in space, are reporting conflicting coordinates, as if Voyager exists in multiple places at once. Its signal, traveling at the speed of light, shows tiny variations in transmission time, suggesting it's passing through regions where space-time itself is warped. These aren't the symptoms of a dying spacecraft. They're the signs of something far more profound. To understand the weight of this moment, we need to step back and consider what Voyager 1 represents. When it was launched, its mission was simple: observe the gas giants, snap a few pictures, and fade into obscurity. No one dreamed it would leave the solar system, let alone rewrite our understanding of the cosmos. Yet here it is, 45 years later, revealing truths we weren't prepared to face. The heliopause, once thought to be the edge of our cosmic neighborhood, now seems like a doorway. Beyond it lies a realm where the rules of physics bend, where space itself feels alive with forces we can't yet name. Voyager's data suggests we've been wrong about interstellar space. It's not empty. It's not silent. It's teeming with activity. Plasma waves, particle storms, and now this mysterious pulse that behaves like a signal. The Nobel laureate's warning echoes in our minds. We may be seeing evidence of another structure of space itself. Another structure. Not just a new region, but a new kind of reality. Let's talk about that pulse again, because it's the detail that keeps scientists awake at night. In the vastness of space, signals don't just appear. Natural phenomena, like stars or black holes, produce radiation, but it's chaotic, predictable in its randomness. This pulse is different, its rhythm is too precise, its responses too consistent. Engineers have triple-checked Voyager's instruments, ruling out hardware failure. The signal is real, and it's coming from the direction Voyager is traveling deeper into interstellar space toward the unknown. Some have dared to ask the unthinkable. Could this be a message? Voyager 1 carries the golden record, a disk engraved with sounds and images of Earth, a greeting to any intelligence that might find it. The irony is almost poetic. The spacecraft we sent to speak for us may have received a reply, but if this is a message, who or what is sending it? The possibilities are as thrilling as they are terrifying. One hypothesis points to a natural but unknown phenomenon, perhaps a new type of cosmic object that emits structured signals. Another suggests we're seeing the echoes of a long-dead civilization, its technology still humming in the void. Then there's the theory that pushes the boundaries of science itself. Voyager may have entered a region where the universe interfaces with something else, a multiverse, a simulated reality, or a construct we can't yet comprehend. The spiral pattern in the magnetic data fuels this idea. It's not just a shape, it's a framework, a lattice that seems to guide the forces around Voyager. Theoretical physicists have long speculated about such structures, calling them cosmic strings or domain walls, relics of the universe's birth. But no one expected to find one, and certainly not with a 1970s spacecraft. The gravitational anomalies add another layer of mystery. Voyager's slight drift can't be explained by any known force. It's not orbiting a star, it's not caught in a planet's pull. Yet something is tugging at it, subtly but measurably. Some scientists wonder if Voyager is grazing the edge of a gravitational anomaly, a region where space-time is folded or stretched. Others propose it's encountering dark matter scaffolding, invisible structures that shape the universe's large-scale architecture. Whatever it is, it's real, and it's affecting Voyager in ways we can't ignore. The spacecraft's conflicting position reports only deepen the enigma. How can a single object occupy multiple coordinates? One physicist, speaking anonymously, suggested Voyager might be slipping between layers of reality, a concept that sounds absurd until you look at the data. Quantum mechanics allows for particles to exist in multiple states. Could the same be true for a spacecraft caught in a cosmic overlap? This discovery comes at a pivotal moment. For decades, humanity has searched for signs that we're not alone, scanning the skies with telescopes and radio dishes. SETI, the search for extraterrestrial intelligence, has listened for signals but found only silence. Now Voyager 1, a machine never designed for this purpose, may have stumbled across the very evidence we've been seeking. The pulse, the spiral, the anomalies, they don't fit our models of a lifeless universe. They suggest intent, structure, perhaps even purpose. But the implications go beyond the question of alien life. If Voyager has crossed into a new domain, it challenges everything, our physics, our cosmology, even our philosophy. Are we living in a universe or just one of many? Is reality a single fabric or a tapestry of overlapping threads? Voyager 1, with its fading battery and outdated tech, is forcing us to confront these questions. Let's not forget the human side of this story. The engineers and scientists who built Voyager 1 are now in their 70s and 80s, many retired or gone. They launched this mission with slide rules and punch cards, never imagining their creation would outlive them, let alone rewrite the cosmos. Today's team, working with technology older than most of them, faces an impossible task: interpreting data from a place no one has ever been, with instruments not designed for this reality. Every command they send is a gamble, every signal a lifeline. Yet they persist, driven by the same curiosity that launched Voyager in the first place. This isn't just a scientific endeavor, it's a human one, a story of resilience and wonder. Voyager 1 is our emissary, carrying not just our technology, but our dreams, our fears, our longing to know what lies beyond. The emotional weight of this moment is hard to overstate. Imagine the scene at Mission Control when the signal cleared, when the first coherent data arrived after months of silence. Picture the scientists hunched over screens, realizing that what they're seeing isn't just unusual, it's impossible. The room must have buzzed with disbelief, excitement, maybe even fear. This isn't a telescope observing a distant star. This is a physical object, built by human hands, touching the edge of the unknown. It's personal. It's intimate. Voyager 1 is us, out there, alone, encountering something vast and incomprehensible. And now, it's talking back. The pulse, the spiral, the drift, they're not just data points. They're a message, a challenge, a mystery that demands we look up and ask, what are we really part of? The Nobel laureate's warning carries a weight that's hard to ignore. This isn't a fringe theorist or a YouTube conspiracist. This is one of the sharpest minds in physics, someone who spent a lifetime unraveling the universe's secrets. When they say Voyager's data cannot be reconciled with our current models, it's not hyperbole. It's a call to action. The scientific community is mobilizing, with teams across the globe analyzing the transmissions, running simulations, and debating what comes next. But time is running out. Voyager's power supply is dwindling. Its plutonium battery, which has kept it alive for nearly half a century, is expected to fail within the next few years. When it does, the spacecraft will go silent forever. Its instruments frozen, its signal lost. Whatever it's found, whatever it's trying to tell us, we have a narrow window to understand it. So what does this mean for us here on Earth? If Voyager 1 has indeed crossed into a new kind of space, it's not just a scientific breakthrough, it's a paradigm shift. Everything we've built, from quantum mechanics to general relativity, assumes a single, consistent universe. But what if that's wrong? What if Voyager is showing us that reality is layered, that our universe is just one piece of a larger puzzle? The spiral pattern, the responding pulse, the gravitational drift, they hint at a cosmos far more complex than we imagined. Some are already calling it the Voyager anomaly, a term that's spreading across academic papers and hushed conversations. Others go further, suggesting we're on the verge of a new Copernican revolution, one that decenters not just Earth, but our entire understanding of existence. The possibility of an artificial signal can't be dismissed. The golden record, etched with humanity's music, languages, and greetings, was a long shot, a message in a bottle tossed into the cosmic sea. No one expected a reply, yet here we are, grappling with a pulse that seems to react, a pattern that looks designed. If this is contact, it's not the kind we imagined. No little green men, no radio broadcast declaring peace. It's subtle, ambiguous, and deeply unsettling. What kind of intelligence would communicate this way through rhythms in plasma and spirals in magnetic fields? What kind of mind could build a structure that spans light years, invisible, until a tiny spacecraft stumbles through it? The questions are dizzying, and the answers, if they come, could change us forever. But there's another possibility, one that's just as profound. What if Voyager hasn't found something out there, but something fundamental about reality itself? The anomalies could be evidence of the universe's underlying code, a glimpse into the machinery that holds it all together. Theoretical physicists have long speculated about a unified theory, a set of rules that explains everything from quarks to galaxies. Voyager's data might be the first clue, a signal from the universe's operating system. The spiral lattice, the warped space-time, the impossible pulse, they could be artifacts of a deeper truth, one we're only beginning to perceive. If so, Voyager 1 isn't just exploring space, it's exploring the nature of existence. As we speak, Voyager 1 is still out there, hurtling through the void at 38,000 miles per hour. Its instruments are still humming, its antenna still pointed toward Earth, sending back faint whispers from a place we can't imagine. Every byte of data is a treasure, a breadcrumb leading us toward the unknown. But the clock is ticking. The spacecraft's power will fade, its voice will falter, and one day, perhaps soon, it will fall silent. When that happens, we'll be left with what it's given us, a puzzle, a warning, a possibility. The Nobel laureate's words linger. This changes everything. It's not just about Voyager, it's about us, our place in the cosmos, and the courage to face what lies beyond. This discovery is a wake-up call. For too long, we've looked at the stars as distant lights, beautiful but unreachable. Voyager 1 is proving there's something more, a frontier, a mystery, maybe even a mirror. The pulse it's detecting, the spiral it's tracing, the forces pulling it off course. They're not just data. They're a challenge to our assumptions, a dare to rethink what's possible. Are we ready for what comes next? If Voyager is indeed brushing against another reality, another intelligence, or another layer of the universe, it's not just a scientific question, it's a human one. What do we do with this knowledge? How do we prepare for a truth that might upend everything we believe? The emotional stakes are overwhelming. Voyager 1 was launched by a generation that dared to dream big, that believed humanity could touch the stars. Now it's delivering a message that could define our future. The scientists poring over its data aren't just crunching numbers. They're wrestling with the weight of history. The engineers sending commands across 15 billion miles aren't just fixing a machine, they're keeping a dream alive. And we, watching from Earth, aren't just spectators. We're part of this story, heirs to a legacy that began when a small spacecraft left our planet nearly half a century ago. Voyager 1 is our voice, our eyes, our heart in the cosmos. And right now it's telling us something extraordinary. So where do we go from here? The scientific community is racing to make sense of the data, but the answers won't come easily. New models, new experiments, maybe even new missions will be needed to follow Voyager's trail. Some are already calling for a successor, a probe designed to explore the interstellar frontier with modern technology. Others argue we need to focus on Voyager, while it's still alive, squeezing every last bit of knowledge from its fading signal. Either way, the journey is just beginning. Voyager 1 has opened a door, and what lies on the other side is anyone's guess. A new dimension, a cosmic intelligence, a truth about reality we've never dared to imagine? Whatever it is, it's out there, waiting. The irony is almost too perfect. Voyager 1, a machine built to explore the known, has stumbled into the unknown. Its golden record, meant to introduce humanity to the stars, might be the key that unlocks a reply. Its simple instruments, designed for a world of planets, are now measuring a world of mysteries, and its journey, once thought to be a lonely drift, might be the first step toward contact, not just with another species, but with another reality. The Nobel laureate's warning is clear. This isn't just a discovery, it's a turning point. Voyager 1 has found something that shouldn't exist, something that challenges the very fabric of our universe. And now, it's up to us to decide what to do with it. Imagine the moment when the final signal arrives, when Voyager's battery gives out and its voice fades forever. Picture the scientists, the engineers, the world, holding their breath as the last data packet streams across the void. What will it say? Will it confirm the pulse as a signal, the spiral as a structure, the anomalies as a new reality? Or will it leave us with more questions? A mystery to haunt us for generations? Either way, Voyager 1 has already done something miraculous. It's shown us that the universe is bigger, stranger, and more alive than we ever dreamed. It's reminded us that exploration isn't just about finding answers, it's about daring to ask the questions. So here we are, at the edge of the abyss, staring into the unknown. Voyager 1, our tiny ambassador, has carried us farther than we ever thought possible. It's given us Jupiter's storms, Saturn's rings, and now